Hi friends, my name is Ajay. I am third year BTech student of IIT Bhubaneswar. In this experiment, I would like to demonstrate the output of the high pass and low pass filter. This is the float array of X, which carries the 1000 samples. These are all the samples, and float by 1, float by 2, float by 3. These are all the arrays which can hold 1000 samples of the output of the high pass filter. These can hold the output of the low pass filters of the frequencies 30Hz, 10Hz and 5Hz respectively. Int s is equals to 1000, which denotes the number of samples which is used for running the loops. Then in the void setup, we are setting the baud rate according to the problem statement given. The sampling frequency is 100 Hz and the cutoff frequency is 0.5 Hz. We have to design the high pass filter. When we do this by pole zero placement method, we will get h of z is equals to 0.9843 z minus 1 by z minus 0.9686. When we convert this into the time domain, we will get y of n plus 1 minus 0.9686 into y of n is equals to 0.9843 into x of n plus 1 minus 0.9843 into x of n. When we convert this into the causal system, that is, we should not have any n plus terms. We should contain only n term and n minus 1 term. So replace the n plus 1 by n. Then we will get y of n is equals to 0.9686 into y of n minus 1 plus 0.9843 into x of n minus 0.9843 into x of n minus 1. So this is the high pass filter. So we are going to give the samples of input to the high pass filter first, and the output of the high pass filter are stored in the array float y of 1000. So this is the code for running the loop. For int I equal to 1, I less than yes, I plus plus, y of I is equals to which I have told you. So this will give you the output of the first high pass filter, and the values are stored in the float array of y of I. Now the output of this high pass filter are given to the low pass filters of y1, y2, y3, which was also given in the experiment. The parameters are like this: fs is 100 Hz, and the cutoff frequencies for y1, y2, y3 filters are 30 Hz, 10 Hz and 5 Hz. So when we do similarly by using the pole zero placement method, we will get the equations for each of the low pass filter and like this. For 30 Hz, we will get y of n plus 1 minus 0.2566 into y of n is equals to 0.3717 into x of n plus 1 plus 0.3717 into x of n. So again we are going to convert this into causal system by replacing n plus 1 by n. When we do this, we will get this equation. So the output of the high pass filter is given to this low pass filter. So we are using in place of x here, we are using y, so that this high pass filter output is given to this low pass filter. So this low pass filter output are stored in the y1. Again y2 is also a low pass filter, which the input is the output of the high pass filter, but the difference between y1 and y2 is the cutoff frequency, which is 30 Hz for y1 and 10 Hz for y2. So similarly we are doing this, and for y3 the same output of high pass filter is given as input, and but the cutoff frequency here is 5 Hz, and we are collecting the output of this low pass filter into y3 array. So this is for y3. So for each term we are calculating the first y3 of 0 by substituting n is equals to 0. So now I will demonstrate how the output of each of high pass filter and low pass filter works. So okay, now my Arduino is connected to my laptop, and now I am going to run this program. Here I am serial print y5, that is the output of the high pass filter, and then I am printing y1 of 5. This is the output of the first low pass filter, which has the cutoff frequency 30 Hz. I am shifting this by 200 volts DC so that we can observe the two plots in a parallelly. So I will show you the output regarding this. Okay then. Okay, the code is being uploaded. Yeah, it's done uploading. I'm just serial plotter. Yeah, you can see this thing. Yeah, this blue one is the output of the high pass filter, and when I sent this input high pass filter into the low pass filter of y1, it is getting smooth. That is, the high frequency, very high frequency components are being suppressed, and the output is like a smooth curve. But we can see that there are many high frequency components. The curve is not smoothed very well. So we will use the another cutoff frequency, that is 10 Hz. So now I will show the output of the 10 Hz by comparing 30 Hz signal. Okay, now I am writing here y1, which is the first low pass filter. Then I am showing parallelly the y2 of 5. This is the second low pass filter, which has the frequency, cutoff frequency of 10 Hz. So now I am uploading the code. We are done uploading. I am opening the serial plotter. See, the curve is not very much smooth. Okay, so now there is no much difference if you see. So 30 Hz and 10 Hz, they don't have much difference. So I am going to use the cutoff frequency of 5 Hz. So in place of y2, I am going to use the y3, so that the third low pass filter will be shown. It's done uploading to serial plotter. Yes, if you observe these two things, the curve is more smoothened, right? So the low pass filter, which with the lowest cutoff frequency, it will remove the high frequency component, so that only the low frequency components are coming. So this is the code, and this is all the program for this video. So thank you.